Activity 1.9 through 1.11 cover function basics. So let's start with a table. The following table lists the official high temperatures in Fahrenheit in Lake Placid, New York during the first week of January. And the first question that we're asked is temperature a function of the date? And then it says explain using the definition of a function. So I'm actually going to write this relationship using function notation. Sometimes it helps me to think about what's happening when I write the words in function notation. So on the side you'll notice I wrote temperature equals f of date. Right? Temperature is a function of date. So whatever comes after the word function would go in the parentheses. So date comes after function, so I put date in the parentheses. And I think you should think of this as the temperature is the output and the date is the input. So I'm going to label that up here. So you can see input and outputs for date and temperature respectively. So remember, the definition of a function says each input has one output. So the input of 1 only has one output, 25. The input of 2 only has one output, 30, right? So for the input date, there's not multiple temperatures for each date. For each input or for each date, there's only one output or one temperature. So I can say this is a function. Right? Temperature is indeed a function of the date. So I'll fill in my answer below. Next question. In this table, temperature is now the input and date is the output. And now we're asked, is date a function of the temperature? Is date a function of the temperature? I'm going to say no, because the input 30 has two outputs. The input 30 has an output of 2, and the input of 30 also has an output of 7. So yeah, I'm going to say no, date is not a function of temperature, because for the date input 30, there are two outputs, 2 and 7. Next, we're asked to look at some graphs. Okay, so the graphs show the points from the first table. Right, so this particular graph is displaying the points from this first table. And we're asked to label the axis. So the first table had date as the input and temperature was my output. The second table had temperature as the input and date as the output. So remember, the input is what you place along the horizontal axis, or sometimes the x-axis, and the output is on the vertical axis, and in some cases we call that the y-axis. Now the book says, note, the second graph, there are 2 points on a vertical line that represents the input 30. It says, if we draw a vertical line and it intersects the graph more than one time, the graph does not represent a function. So when I look at graph 1, if I were to draw a vertical line through each of my inputs, you would see that the graph never intersects the vertical line more than one time. Whereas in the second graph, well, for the input of 30, we have a problem because the graph intersects the vertical line 2 times. So graph 1, we would say this is a function. Graph 2, we would say this is not a function. Moving on, we're given a definition. The vertical line test. A graph defines a function if any vertical line drawn through the graph intersects the graph at most one time. So let's take a look at problem number 3. We're asked to decide if the graph represents a function. So I just am going to draw a vertical line through each graph and see if they intersect once or more than once. So the first graph fails the vertical line test. So I'm going to say this graph is not a function because you can see this vertical line intersects the graph twice, once over here and once down here. So let's take a look at the second graph. So it looks like when I draw a vertical line, it only intersects the graph one time. And I can draw multiple vertical lines, and at most, each line will only intersect the graph one time. So we can say this graph represents a function. Next, we have some fill in the blanks. In all functions, the output variable is called the dependent variable since it depends on the input. which is the independent variable. The collection of all possible values of the input variable is called the domain of the function. The collection of all possible values of the output variable is called the range of a function. The values of input or output that make practical sense in the context of the problem are called practical domain or practical range.